Personal finance practice problem using OneNote. Present value and future value mathematical formulas problem number 2. Prepare to get financially fit by practicing personal finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side. We're in the Practice Problems tab, down in the 1117 Present Value and Future Value Mathematical Formulas Prob 2 tab. Also note, when using OneNote, look at the Immersive Reader tool. Our practice problems will also be in the text area with the same name, same number, but with transcripts. Transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we got our information up top, calculation on down below. We're going to be looking at present value, future value from the standpoint or calculation method of mathematical formulas. But before we get down there, we're going to recap what we have done in prior practice problems. You don't need to have done the prior practice problems to move forward, but we want to get an idea of the way you can do different kind of practice problems or different calculations for the same thing so that you can understand how to do them, how to apply the best method, and how to know what other people are doing if they use a different method than you would. So the information up top is the yearly earnings percent of an investment is 12%. In other words, we are imagining an investment that would increase annually at 12%. At least that is our estimate. The investment could be something like stocks. It could be bonds. It could be a savings account. It could be land. It could be basically a home or something like that, which we are assuming it's going to be going up on an annual basis at the 12%. Question then, how long will it take for the investment to double, which we could find without even knowing what the investment amount is that we're starting with by using the rule of 72, and that's what we started out with. That's an approximation answer. Then, and oftentimes, it makes it more concrete to actually have an investment amount, which if they don't give you one and you try to calculate the problem in like a book problem or something like that, you might want to pick like 100 or 1000 so that it can help you to get some bearings on how the calculation would work and how it would look if you were to double it, 100 double into 200, 1000 double into 2000. We here are going to use the investment of 2000 because it's the second problem and we just want to pick a different number than 1000 or 100 to show that it would work in that format as well. Therefore, we're looking at the time frame at which that 2000 would double, which was of course making it 4000. We did the rule of 72, 72 divided by 12, because the percent was 12%, we got approximately 6 years. We also did the running balance, doing the calculation, interest accruing upwards. Very useful calculation, no matter what method we do, because it gives us more detail about the details. And we found that between year 6 and 7, we went from 3,000 to 4,000, clearing that doubling threshold. We then looked at the functions in Excel, calculating the answer with the present value, the future value, and the number of periods calculations. And now we're going to move on down to the mathematical formulas. And this is something you might see, of course, in a text situation, or if you're in a course where they'll start off usually with the mathematical formulas, and then they might try to take away your calculator and either force you to use a mathematical formula, or for more complex calculations, they'll give you tables that we'll take a look at next time to do the calculations. In practice, most likely you would be using Excel to do these types of calculations, or a financial calculator. I think Excel is even more prevalent these days than a financial calculator. So here's the calculation. We're going to use the present value and future value calculations. Remember that the answer that we're looking for right here isn't actually a present value or future value calculation. We're looking for the number of periods at which this thing will double. If we start off and first look at a present value calculation, the end result of the present value calculation would be basically our starting point, which in this case we're going to assume 2000. The ending point or future value we know is going to be twice that, or 4,000. So you might say, well, don't I need another formula that's going to be solving for the number of periods? Which of course you could do, because you could rework it algebraically, but most people will know the present value and future value formulas before they know the reworking of some other unknown component, such as the number of periods, and simply use algebra then to back into the unknown, which we can do in this case with either formula, present value or future value. those two formulas being related. So for example, present value equals the future value times, or you can say the future value as the numerator over 1 plus r, the rate, to the number of periods, or n. Now we know everything here that we can solve for one unknown. We know the present value. The present value is going to be 2,000. You can see it written down here algebraically. Equals, we know the future value. That's going to be our ending point, doubling the 2,000 to 4,000, over or times 1. So we're going to say over 1 plus r. R is going to be 0.12 or 12%, caret or to the number of or the power of the number of periods, which is going to be, in our case, the unknown. Once you have it written algebraically here with one unknown, you can then solve for the unknown. We're not going to work the algebra from here. I'll let you kind of work the algebra if you want to solve it in that format. What we're going to do is take this data here and put it into a format of a table, not reworking it and solving for n, but rather putting it in just as it's shown here in this format, practicing how to put an equation into a table type of format similar to a tax return or financial statements, and then seeing the unknown component as n as part of the equation and thinking about how we can use trial and error to figure that out, which would be tedious if done paper and pencil and a calculator, but which is quite easy if done with Excel using a tool called kvlccwl, and very applicable, especially if you're using more complex functions like we saw up top, where we cannot easily rework it using algebra and might want to use a tool such as kvlccwl to back into some kind of calculation within our table. So let's do that. We're gonna bring this into a table. Now, when we look at our table, if I was to make this into like a tax return or a financial statement kind of table, I would like to have the numerator and the denominator, in essence, in the outer column. Any other subcategory calculations we're going to have in the inner column and indicate those subcategory calculations generally. So the numerator is going to be the future value we'll have at the start of the table. It's going to be in the outer column at the 4,000, which is the 2,000 times 2. That's going to be our ending point because we're looking at the point at which the starting point, present value, 2,000, doubles, and how long it takes for that to happen at a rate of 12%. Then we're going to have the denominator, which is the 1 plus r to the n. I'm going to put in as a subcategory 1 plus the r to the caret of n periods. Indicate that we're going to bring this inside by the colon here. That's going to indicate that we're going to have a subcategory that won't be in the outer column. That will also be indicated by the indentation down below as well. So we're going to say 1 or 100. So we got 1 plus r. Obviously, the 1 could be represented as a number 1. It could be represented as a percent, which would be 100%, plus r. R could be represented as the 12%, or it can be represented in decimal format as 0.12. And then, of course, if we were to add those up, we'd get the trusty calculator. We could say 1 plus 0.12 is going to give us 1.12 or 112%. Then we're going to take that 112%, which is the subcalculation of 1 plus r to the power of n. N is going to be our unknown. We don't know what n is, and if we had our table here in Excel, we might set up another cell out here to indicate the unknown component happened to having the answer in it at this time. But if we didn't know what it was, we wouldn't want it 0. We wouldn't want to leave it blank. We can put some number in there like 10 or something like that, noting that that's the cell that we're going to be changing or asking Excel to change to get to the end result to what we know it should be, which we're going to say is 2,000. So then we would take the 112 to the power of 6.12, which I'll do shortly. And that would give us the 2 in this case, which of course is the right answer, because then we can divide out the numerator divided by the denominator, or 4,000 divided by 2. That would then give us the 2,000 correct response. Now note, you can imagine a situation where if we just picked a number right here like 10 or something like that, we would get an answer that would be incorrect. And we can then adjust this manually. It would be difficult to do algebraically, but easy to do in a computer, changing it to 9, to 8, to 7, and so forth until we get to the end result being closer to what it should be just by using trial and error. We can then use kvlccwl within Excel to basically find, in essence, the exact number that would give us the end result, which is correct, which is useful to know here because if you have a table format, that can be useful. It's also useful to know because that will be applicable as well if we have multiple complex functions that will be involved in more complex calculations up top. So if we then did that, we get to the right answer of the 6.12, which if we calculate that out, we got if I wanted to take this to the 112 to the power of 6.12, remember you will need a calculator to do that. And here I'm going to pick up the scientific calculator, make sure I got the capability to do that. So I'm going to say 1.12, and it's going to be to the xy or caret to the power of the 6.12, and note that this is rounded to 2 decimals, so this is still an approximation, which is giving us about 2. So that gives us the about 2, the 4,000 divided by 2 giving us then that 2,000. So I'm going to bring this back to the standard calculator, and there we have it. Now we could do the same kind of thing with the future value because we're looking for n here. We have the same, all the components except for one unknown. So you might view this, someone else might view this and say, well, this looks like a future value calculation, and I'm just going to solve for the unknown. But they could do that too, because the future value is something we know. We know what the future value should be. It should be double the starting point because we're looking for the time frame at which it will double, which will be twice 2,000 or 4,000. We know the present value. The present value is going to be the starting point, or 2,000, times 1 plus r, the rate, which is 12%, which can be written as 0.12, to the power of the number of periods, n being the unknown. We can then use our algebra to solve for the unknown. We're not going to do that here, so you can work that here. What we're going to do is take this formula once again, or the different formula, future value formula, put it into a similar table as we did with the present value, and run a similar type of calculation. So we've got 2 components here, present value and the 1 plus r to the n. So if I'm going to build a table on this calculation, I would typically, like a financial statement or a tax return type of calculation, table format, I would like this 2 components in the outer column so that I can multiply them together. Any more complex component, like the 1 plus r to the n, I will have in the inner column here to do that kind of calculation. So the present value outside is going to be the 2,000. That's the original investment. That's our starting point, the present value. We're going to have the 1 plus the rate to the n. That's going to be our subcalculation representing the second half, which we're going to pull into the inside the total number then, or the total calculation related to it, then it's going to be pulled out to the outside. So then we have the 100%, which is the 1, which could be represented as 100% or simply 1. And then we're going to add to it the rate, which could be represented as 12% or 0.12. Adding them together will give us 1.12 or 112%. We then have that to the power of n, which is the unknown. That's the number of periods. Also note, as we do this subcalculation, we brought this inside indenting it, and we brought it to the inner column, both indications that this is kind of a subcalculation that we're going to have here to get to the end number that we're going to multiply them two together. So this would be the one that, this is the item that we would be guessing over here in the goal seek. It's actually 6.12, even though we show 6 here. This is the answer, but if we didn't know the answer, we could populate this cell if it was in a table format and guess something like 10, not leaving it at 0 or blank, because those factors can actually mess up the calculation, right? So you want to put some number in there typically so the calculation makes some sense, and then use that number to then adjust to get to your end result, to get to what you know it should be. The end result should be 4,000. If you're using Excel, you can do that easily with the goal seek feature. So then we would say the 112 to the power of 6 gives us 2, and then we're going to multiply those two together here. Multiplying the outer column, 2,000 times 2 would of course give us the end result, which in this case is the correct answer of 4,000. If we put something like 10 in this column or in this box here instead of the answer, we can then see trial and error or use trial and error until we get the end result to the proper result, which would be difficult if we did it with the trusty calculator, but easy if we do it with something like Excel. And again, it leads into the concept of us being able to set up a table like this if it was a more complex table, if it used functions for us to kind of back into it using that trial and error method. So if we have the right answer, I'm going to imagine this is 6.12 because it's missing the 2 decimals, even though it's calculating using them. We would take then, I'm going to pull out the trusty calculator. make that a scientific calculator. And this is going to be the 1.12. We're going to take that to the power of x to the y, puts the caret up top, and we got about 6.12. So we're going to say 6.12 about, and say equals, and that gives us about 2 because it's still rounded. And then the 2 times the 2,000 gives us our result of the 4,000. So this is another way we can do these calculations. Just remember, no matter what way, this way is still giving you kind of this magic number of 6.12, which it's useful to also do the running balance calculations where you can, again, see the interest as it actually compounds. This is another format that's hard to do by paper and pencil, but quite easy to do with spreadsheet programs and worthwhile to spend some time knowing how to put together.